All right, I wanted to make a quick review sheet for some of the problems for the radicals test that we're going to have in next class. I've decided to do 4 problems. Page 372, number 23, page 377, number 19, page 378, number 50, and page 382, number 23. For page 372, number 23, the directions read, simplify each radical expression. Use absolute value symbols when necessary. The problem reads the square root of x to the 8th, y to the 18th. Now, since the index is 2 and it's even, what we're going to do is we're going to get each, if we can, each variable term to be something to the second power. So instead of x to the 8th, we're going to write x to the 4th to the second power, so that's raised to the same power as the index, and we're going to get y to the 8th to become y to the 9th to the 2, so that is also to the second power, which is the same as the index. Now, if you look inside the parentheses at that exponent, because x to the 4th is even, that does not need to be within absolute value symbols. Because y to the 9th is raised to an odd exponent, that y to the 9th, when taken outside of the radical symbol, does need to be within the absolute value symbols. So when you simplify that radical expression, if you're going to use absolute value symbols, then what you do is instead of writing the square root of x to the 8th, y to the 18th, you write x to the 4th times the absolute value of y to the 9th. Moving on to number 377, page 377, number 19. The directions read, multiply and simplify, assume all variables are positive. When it says assume all variables are positive, you no longer need to worry about putting anything within the absolute value symbol. If we're going to multiply the square root of 7x to the 5th times the square root of 42 xy to the 9th, what I did was I factored the 7 and the 42. I put everything underneath the same radical sign. So instead of 7, x to the 5th, I have the 7 as a factor next to the factors of 42, which are 2, 3, and 7. So for all the numbers, my factors are 2 times 3 times 7 times 7. That's equivalent to 7 times 42. X to the 5th times x, or x to the 1, is x to the 6th. And then we have y to the 9th as a factor. Now, I can take a pair of 7s, cross them out inside, bring 1 outside. That leaves me with a 2 and a 3 as the numbers inside the radical sign, and that 2 times 3 is 6. X to the 6th factors to 2 sets of x to the 3. So I bring x to the 3 outside. I have no x's remaining inside or underneath the radical symbol. Y to the 9th is y to the 4th times y to the 4th times y to the 1. I can bring a pair of y to the 4ths outside, leaving a y inside. After I multiply and simplify, I have remaining 7x to the 3rd, y to the 4th times the square root of 6y. The next problem that I decided to do was page 378, number 50. It says, simplify each expression, rationalize all denominators, assume that all variables are positive. So again, no need to worry about absolute value symbol. We start off with the cube root of 14 divided by the cube root of 7x squared y. Because the indexes are the same, or indices really, are the same, I can put them all under a cube root of, I can put them all under the cube root radical, which would leave me with the cube root of 14 divided by 7x squared y. I can simplify the 14 and the 7, which gives me a 2 in the numerator and a 1 in the denominator. So it can be rewritten as the cube root of 2 divided by 1x squared y. I don't really need to write the 1, I just put it in there to show you what happens when you simplify the 14 and the 7. Then I'll go back and I'll write that as the cube root of 2 divided by the cube root of x squared y. Now, I need to rationalize the denominator, which means I need 3 factors of x, I only have 2 of them, and I need 3 factors of y, I only have 1 of them. I need 1 more factor of x, and I need 2 more factors of y. So I'm going to multiply the numerator and the denominator by the cube root of what I need. I need a factor of x and I need two factors of y. So I'm going to multiply the numerator and the denominator by the cube root of xy squared. X squared times x is x cubed. When I take the cube root of that, I have an x outside the radical sign. Y times y squared is y cubed. When I take the cube root of y cubed, I take a y outside the radical sign. Since I have nothing left inside the radical sign, it goes away, and thus the denominator is rationalized. In the numerator, I have the cube root of 2 times the cube root of xy squared, which simply leaves me with the cube root of 2xy squared. So my solution, after I rationalize the denominator and simplify the expression, the answer, I should say, is the cube root of 2xy squared divided by xy. Moving on to number 23 on page 382, the directions read rationalize each denominator and simplify the answer. Now, I have 4 divided by 1 plus the square root of 3. I cannot simply multiply the numerator and the denominator by the square root of 3 because I have 1 plus the square root of 3. That's an entire factor because that can't be simplified. So I need to multiply the numerator and the denominator by the conjugate of 1 plus the square root of 3. The conjugate of 1 plus the square root of 3 is 1 minus the square root of 3. And the reason why you do that is because you'll eliminate your radical terms. What you're left with, in essence, you have a plus b times a minus b, which will give you a squared minus b squared. So when I do that, in the numerator I have 4 times 1 minus the square root of 3. In the denominator, I get 1 times 1, which is 1, minus the square root of 3 times the square root of 3, which is 3. Or I'm left with 1 minus 3 in my denominator. 1 minus 3 is negative 2. So I would have 4 times the quantity 1 minus the square root of 3 divided by negative 2. The 4 and the negative 2 simplify to negative 2 in the denominator. Negative 2 in the numerator, I apologize, over 1, so we don't have to write the denominator. And the answer is negative 2 times the quantity 1 minus the square root of 3. If you have any questions about these or any of the others that I assigned to work on for your study session, then let me know before we start the test and I'll answer all those questions. Have a great day. Math it up.